Alright, so this is what I think is the easiest way to memorize the entire unit circle. So, here's the thing. You have to do some memorization, but not nearly as much as memorizing every single point on the circle, right? So, you are going to have to memorize the first quadrant. So, I'm just going to draw that out. So, the first line is pi over 6. The next line is pi over 4. And the next one is pi over 3, right? So first we have 0, and then this one is 0. I didn't leave space for that, whatever. So this point is 1 comma 0. This point is root 3 over 2 comma 1/2. This point is root 2 over 2 comma root 2 over 2. And this point over here is 1/2 comma root 3 over 2. And then finally, at pi over 2, we have 0 comma 1. Alright, so first step, memorizing the entire unit circle. This is the only memorizing we have to do, is memorize this first quadrant, everything I wrote down. But here's the thing. I'm going to show you some tricks quickly to help you memorize it even better. So first of all, at pi over 6, we have the point root 3 over 2 comma 1/2, right? So first I want to show you the value of root 3 over 2 is equal to, if we look, root 3 over 2 is equal to 0.866, and the value of 1/2 is equal to 0.5, right? So that means that root 3 over 2 is greater than 1/2, right? So that's, you may be wondering, like, why is he telling me this? Alright, so if you look here, we go over a very large amount, right? And we go up a very small amount. And the small amount is 1/2, since 1/2 is smaller than root 3 over 2. And root 3 over 2 is the big amount because root 3 over 2 is bigger than 1/2. So we know when we have pi over 6, we go over a lot and up a little. So over a lot means root 3 over 2. Up only a little means 1/2, because root 3 over 2 is bigger than 1/2. Now, this same concept applies at this point right here, pi over 3. So if you look, we're going up a lot, but only over a little bit, right? So since we're only going over a little bit, we have 1/2 as our x variable. And since we're going up a lot, we have root 3 over 2 as our y. Because when whatever is bigger, if over is bigger, then we use root 3 over 2. But if over is smaller, then we use 1/2. Same way, if the amount we go up is really big, then we use root 3 over 2. And if the amount we go up is really small, like in pi 6 case, we use 1/2 for our y. So you still have to memorize the values root 3 over 2 and 1/2, but it's nowhere near as, like, you still have to memorize root 3 over 2 and 1/2, but this little trick helps you know where each one goes. And then for pi fourths, you just know that every time it's in the middle of a quadrant. So pi fourths, or right here when we have 3 pi fourths, or right here, or right here, we just have the root 2 over 2 comma root 2 over 2. It's always root 2 over 2 and root 2 over 2. And then for these ones where it's here, or here, or here, or here, all the 4 corners, it's just 1 and 0. 0 and 1. It's always a 1 and it's always a 0. And you can remember the difference between those two by just thinking about a normal graph, right? So if we have a normal graph and we have this point right here, the point at 0, we have that point. What's this point on the graph? Well, we go over 1 and we go up 0. So it's 1 comma 0. And that's right, same as right here, 1 comma 0, right? You just think it's just like a normal graph. There's just a circle drawn on it. So now if we have this point here at pi over 2, Let me extend this a little bit. So if we have a point up here like that, we just think, okay, well, if this was a normal graph, what would that point be? And we go over 0, and we go up 1. So it's 0, comma 1, right? So you can use that to make sense of those points. And then now, okay, so you've memorized the first quadrant. Cool, you used all my tricks. You figured out how to memorize it. Awesome. Now, what about these last 3 quadrants, right? I said that's all the memorizing you have to do, but how can I know these next 3 without memorizing? Well, it's pretty simple. You just have to use the concept of reflections. So if you remember, let's draw my basic graph again. If I have a point here, so that's 1, we'll say that's 1, 2. I have a point here, this is 1, comma 2, right? So if I reflect this point over the y-axis, it just turns into -1, comma 2, right? I'm taking this point and I'm reflecting it over the y-axis. And so the y value doesn't change, but the x value does change because it's still the same height up. It's just on the different side, so it's going over to the left instead of over to the right. So we use that same concept when we're trying to figure out what the rest of these values on the unit circle are, right? Because remember before I said this is just a normal graph with a circle drawn on it. So let's draw these. So we got that, we got that, and we got that. Okay, so here is 2 pi thirds, 3 pi fourths, and 5 pi 6. And this one is pi. Okay, cool. So 5 pi 6 is comparable to pi 6 because they're on the same point of the graph, just reflected over the y-axis. So when we reflect something over the y-axis, like I said before, we got that, boom, boom. This is 1, comma 2. When we reflect over the y-axis, you just take the x variable and you make it negative. So this would be, if you have a point here, this would be -1, comma 2, right? The x turns negative, but the y stays the same. So for pi 6, if we use that same concept, we have √3/2, comma 1/2. So we reflect it over, the x variable turns negative, so we have -√3/2, and the y stays the same. So we just have another 1/2. Now let's go over to 3 pi fourths. Or, I'm sorry, yeah, 3 pi fourths and pi fourths. So pi fourths is √2/2, comma √2/2. So what's 3 pi fourths? Well, we just reflect it over the y-axis. So if we draw our point, we make the x negative, -√2/2, and we keep the y value the same, right? And now finally, 2 pi thirds corresponds with pi thirds. Let's do the same thing, reflect it over the y-axis. X variable turns negative, -1/2, comma, a positive √3/2, because we're keeping it the same, right? And now for pi, we do the exact same thing. Pi corresponds with 0. So if we take 1, comma 0, and we just make the x negative, we have -1, comma 0. And boom. We figured out the second quadrant without doing any sort of memory. Well, we memorized the first one, but we didn't have to memorize the second quadrant. We just figured it out using math principles like reflections. Okay, cool. So next we're going to do this third quadrant. And this third quadrant, again, we're just going to use a bunch of reflections to figure out what these values are. So first I'm writing the pi values. So here we have 7 pi over 6. Here we have 5 pi over 4. And here we have 4 pi over 3. Alright, cool. So now for this one, the only difference is we're going to use the values from the second quadrant to figure out the reflections. We're not going to use the values from the first quadrant anymore. We're going to use the values from the second quadrant. Alright, cool. So we're going to start with 4 pi over 3. That, as you can see, corresponds with 2 pi thirds. So we're just going to do a reflection over the x-axis this time, right? So let's talk about reflections over the x-axis quickly. Let's not do that. Yeah. Okay, so say we have a graph here. We have our point 1, comma 2 right here. And now we're going to reflect it over the x-axis. So we're going to take it and we're going to drag it across the x-axis just like that. So we have this right here. Okay, so now when we reflect it over the y-axis, we turn the x variable negative. Okay, so now when we reflect over the x-axis, we're just going to make the y variable negative. So this 1, 2 reflected over the x-axis is just 1, negative 2. Because this x is still 1, but when we take it down, now the y is negative 2. Does that make sense? Okay, cool. So we have that. So now we're going to focus on the third quadrant. So we have 4 pi over 3, and that corresponds with 2 pi over 3. So we're just going to do reflection over the x-axis. So x stays the same, negative 1/2, and now we just make y negative. So we have a negative root 3 over 2. Alright, now we have 5 pi fourths corresponds with 3 pi fourths. So we're just going to do a reflection over the x-axis. The x variable will stay the same, so we'll have negative root 2 over 2. But now we'll take the y variable and we'll flip its sign. So in this case, it becomes a negative root 2 over 2. Alright, so finally, we have 7 pi 6. This corresponds with 5 pi 6. And we're just going to do another reflection over the x-axis. So the negative root 3 over 2 stays the same. But now we're going to take the 1/2. We're going to flip its sign to make that a negative 1/2. Cool. And then now we're going to do the fourth and final quadrant. So we're going to draw that there, draw that there, draw that there. Alright, so here we have 11 pi over 6. We have 7 pi over 4. We have 5 pi over 3. Okay, so now, again, we're reflecting over the y-axis again. So if you remember our rules with reflecting over the y-axis, we just take that, we reflect that one to there. It becomes the opposite x variable. So a negative 1, 2 would turn into, we flip the sign on the x, a positive 1, 2. Alright, so we're going to start with 5 pi over 3. This corresponds, we check over like that. That corresponds with 4 pi over 3. So for 4 pi over 3, we're going to take the x variable, we're going to flip its sign. So we have a negative 1/2. Now we have a positive 1/2, and the y variable will remain the same as negative root 3 over 2. Alright, 7 pi fourths. This one is another reflection over this y-axis. We reflect it across there. Alright, so the 7 pi fourths corresponds with 5 pi fourths. We're going to take the x variable and we're going to flip its sign. So the negative root 2 over 2 will become a positive root 2 over 2, comma, a negative root 2 over 2. Alright, finally, we have 11 pi 6, and this one corresponds with 7 pi 6. So again, reflection over the y-axis, and this just equals the negative root 3 over 2 will turn into a positive root 3 over 2, and the negative 1/2, since it's the y variable, will stay the same and be a negative 1/2. Cool. And then I forgot to do 3 pi halves over here. So for 3 pi halves, if you notice, right, there really isn't like I reflected all the fourth quadrant stuff over the y-axis, but for 3 pi halves, or 3 pi over 2, there really isn't any y-axis to reflect it over. So I'm just going to look all the way up to over the x-axis, just like that. So I'm going to reflect it with pi over 2. So pi over 2 is an x-axis reflection, which means that the x variable will stay the same. So we're that, and then the y variable will flip. So we have a 0, comma, a negative 1 for 3 pi over 2. And that is the entire unit circle. All we did was we memorized this first quadrant. That was the only thing we memorized. And then we used reflections to figure out all the rest of the quadrants. Cool. So let's review everything we talked about. First off, you got to remember the first quadrant. It's quite unfortunate, but hey, you got to do it. So at pi 6, it's root 3 over 2, comma, 1/2. At pi fourths, it's root 2 over 2, comma, root 2 over 2. Remember, when it's in the middle of a quadrant, when it's something over 4, it's always root 2 over 2, and root 2 over 2 is just some of them are negative, some of them are positive. right? And then at pi over 3, we have 1/2 comma root 3 over 2. So the same thing with how if it's over a 4, it's always root 2 over 2 and root 2 over 2. If it's over a 6 or a 3, so if it's not in the middle, if it's like kind of like here, like kind of on the left or right side of the quadrant, then we know it's a root 3 over 2 and a 1/2. So pretty much the numbers you got to remember is root 2 over 2, root 3 over 2, and 1/2, right? So we have that, and now so say for pi 6, right? Well, okay, what comes first, root 3 over 2 or 1/2? I know since it's over a 6, we have a root 3 over 2 and 1/2, but which one comes first? So if we think of pi 6, right, it's really big, going over a really big area, and you're only going up a very small area. So that means that since root 3 over 2 is bigger than 1/2, the big one is root 3 over 2, which means we go over x a lot. So x is root 3 over 2. And since we only go up y a little bit, y is 1/2, right? Okay, cool. So we've memorized that. Now you just use reflections to figure out what the signs are on all of the coordinates, and then just like that, you got everything memorized. So if you just figure out, so let's say, what is the variable at 5 pi over 4? All right, so what you're gonna have to do is you're gonna have to in your head envision like a unit circle, right? So we're gonna draw a unit circle. We're gonna figure out where's 5 pi fourths. So this is 1 pi fourth right here. Here is a 2 pi fourths. Here's 3 pi fourths. Here's 4 pi fourths. Here is 5 pi fourths. All right, cool. So we're going to go here. All right, so we know it's in the middle. So we're going to go all the way back to our first quadrant, right? And we know that here it's root 2 over 2, comma root 2 over 2. And now we're going to reflect it once, reflect it twice. And since we're doing two reflections, both signs change. So we have a negative root 2 over 2 and a negative root 2 over 2. So the coordinates at 5 pi fourths are negative root 2 over 2, comma, negative root 2 over 2. Cool. All right, we're going to get rid of all that. All right, now finally you may come across questions like, what is cosine of pi over 6, right? Okay, so, or you might come across like sine of pi over 6, right? So here's what we do to figure out the cosine and the sine. So when you ask for the cosine over the sine, it's referring to this coordinate right here. It's going to be one of those two numbers as the answer. So I just remember it like this. Since cosine starts with a C and sine starts with an S, C comes before S in the alphabet. So I know that the first number in the coordinate is the cosine. So cosine of pi 6, we find pi 6, we look at the coordinate, it equals root 3 over 2, comma 1/2. All right, cosine comes first in the alphabet, so we know the first number is cosine. So the first number is root 3 over 2. For sine of pi 6, we're going to find pi 6, find the coordinate, sine and cosine. Sine comes after cosine in the alphabet, so we know the second number is the number for sine, so sine of pi 6 is 1/2. And that applies for all of the coordinates here. It's just the first number is the cosine, the second number is a sine because C comes before S in the alphabet. So yeah, all this stuff, it's not like super mathematical, right? It's like the big one is root 3 over 2. The small one is 1/2, right? C comes before S in the alphabet. It's not like mathematical, but it's what makes sense in my head. It what helps me memorize the unit circle, because every time I'm asked like, oh geez, what's the sine of 4 pi over thirds, I can just think of the first quadrant and then I can use reflections just to figure it out. So I don't have to memorize this whole circle. I just have to memorize a few values and their corresponding coordinates.